These are the solutions for the third practice quiz for the first quiz in the second trimester. So again, you'll want this little page of notes. So just go left to right with this function in the multiplicity table. So the first, we have x minus 3, so that first 0 is 3 and the multiplicity is 3. And then we have x minus 2. The 0 is 2 and the multiplicity is 2. And then we have 2x plus 1. The 0 is negative 1/2 and the multiplicity is 3. What is the leading coefficient in this? So we need to do negative 4 times 1 to the third times 1 squared times 2 cubed. And that is negative 32. So 8 times negative 4. Again, multiply this out. I'm going to let you do that and figure it out because it's stuff that we've covered in the past. And you should do a couple of these just to make sure that you know on the standard form. Make sure you know. Now, this is an odd degree. It has a degree of 3. Add the powers 2 and 1. The leading coefficient is 2, so it's an odd positive. You can get the end behavior also by looking at the graph. Take a look at the graph. You'll see that it comes way down off to the left and it goes up off to the right. Y-intercept, negative 6. So you can get this by doing 2 times 1 squared times negative 3. Okay, and then leading coefficient you could get by doing 2 times 1 squared times 1. All right, so the 0 multiplicity table with x plus 1, negative 1, and then that's a multiplicity of 2, and then with x minus 3, 3 is the 0, the multiplicity is 1. So negative 1 and 3 and negative 6 down here is the y-intercept. So we're going to come up and we're going to bounce back, come down to the y-intercept, cut through, and then up through 3 and continuing to cut through. Not a very good turn there, but you get the idea. In pre-calc, you'll learn how to find those maxes and mins and how to be much more precise on your sketching. Problem 4. So we have an even degree of 4, 3 plus 1. We have a positive leading coefficient of 1, so 1 cubed times 1. The y-intercept is negative 3, so that's 1 cubed times negative 3. To figure it out, left end behavior is net positive infinity, positive infinity. Again, if you don't have the page of notes, just use your graph to check it out. There's my little 10-minute reminder again. So x plus 1 and x minus 3. So negative 1 and 3 on the multiplicity. Remember, the multiplicity is the power on the factor. Okay, so negative 1 and 3 and negative 3. And when you come down, you flatten out. And it's going to turn back around and cut through at 3. So we flatten out because negative 1 is a triple root. It gets flat there. Are we ever going to have like a multiplicity of 4 where a double root gets flat and it bounces back? It's possible, but I probably won't give you one. Number 5. So here you're going to want to use a 0 finder, and you're going to get 0, negative 3, and 2. So this is what you're going to fill out first on this. You can't just jump here. You got to do this first. So that's x, x plus 3, and x minus 2. And then they're all multiplicity of 1. When you use your 0 finder, it will tell you the multiplicity. So we have x times x plus 3 times x minus 2. So we have an odd positive leading coefficient. Y-intercept is 0. And left end behavior, negative infinity, right end behavior, positive. Again, look at the graph. So here's the graph. I'll show you the answer key picture. So we're going down to the left, up to the right. The simplest way of doing that. So -3, 0, and 2. And there's nothing strange going on here. We cut through, we turn around, come down, turn back around, and go through 2. Nothing too strange. And number 6. So at -1, we have what looks to be like a triple root. And then at 2, we have a single root. For sure. Based on the look on that graph. So, make sure you write the factor correctly. A lot of people get lazy and they forget to switch the sign or adjust properly from the rational 0. It has to be a rational number to write a factor. So make sure you're doing that right and remembering the rules for doing that. So our degree is 4. It's even. Positive leading coefficient of 1. Y-intercept is 2. So we go back here. 1 cubed times 1. And then 1 cubed times -2. So again, where am I getting these? So it's the coefficients on x to the powers on the outside of the parentheses. And then it's the last constant in the parentheses. 1 to the third, -2 to the first, to get the y-intercept. So you can tell from the graph that we have n behaviors of positive infinity there. This is really pretty simple. Just make sure that you write the factors correctly. Okay. Substitution game again. And oops, I forgot. Let me just go another line here. I got to put 1 in too. I'm getting tired, so I'm making mistakes. It's always good to have a great night's sleep and to be very well rested when you do math. So -10 is -b, and 10 is b. I'm going to divide by -1. Be well rested. All right, this one's a little different. So we're solving a quadratic linear system, and we want to find the 2 points of intersection here. So take everything to one side, and then solve this for, you can use a solver, you can factor it if you want, x minus 3, x minus 4. So 3 and 4. But now you got to tell me what are the y's. So you got to come back up here, come to the second one, and put 3 in. So 2 times 3, 6 minus 8, -2. And then put 4 in. 2 times 4, 8 minus 8, 0. You could also use your table to look at it. Okay, I've shown that to you in the past, but this is a linear quadratic system that we had from the last trimester.